Convinced that this device doesn't like me because it continues to cut me off, so hopefully I can get through going over question 10 without being cut off. So we'll see. The last one we have to do, this is now chapter 4 review video part 3. Okay, part 2 was posted about questions 8 and 9. So now let's go over question number 10. Okay, you guys can see that I have overlapping triangles. It's actually very similar to question 8. So I'm going to draw my overlapping triangles. I have triangle WXY, and then I also have triangle ZYX. So those are overlapping triangles. So let's start with the given, and what I like to do, like I mentioned up in question 8, is I like to label my given on both triangles. So here we have, it's given to me that triangle WXY is congruent to, angle WXY is congruent to angle ZYX. So I have WXY. I like to label that on both pictures. So WXY is congruent to ZYX, and then it also tells me that WX is congruent to ZY. So I'm going to label that on both triangles. WX is congruent to ZY. Alright, so that's the given, and now just like overlapping problem number 8 that talked about overlapping triangles, notice they share a side. They share side XY. So I can say that XY is congruent to XY by the reflexive property. So I'm just going to write reflexive property there. So what we've done already is we've already proven now that our two overlapping triangles are congruent by side, angle, side, side, angle, side. So I'm going to write that. I'm going to write in here triangle WXY is congruent to triangle ZYX by side, angle, side. Now what we're going to want to do is we want to look at what we're trying to prove. We're trying to prove that WR is congruent to RZ. So we have to take into consideration what triangles is that a part of. Well, you can see that WR and RZ are a part of triangle WRX and triangle ZRX. So if I could somehow prove that these two smaller triangles are congruent to each other, then that I could say that WR is congruent to RZ, which is what I'm trying to prove by CPCTC. So that's kind of the thought process that's going through my mind right now. We've just proven the overlapping triangle is congruent, so now we want to think, why did we do that? Well, what is an angle that's a part of our overlapping triangles that's also a part of the two smaller triangles that we want to prove congruent? Okay, well if you look, angle W here and angle Z are a part of both triangles. Right? They're a part of my overlapping triangles, and they're also a part of the two smaller triangles. So I can say that angle W is congruent to angle Z by CPCTC. And what that allows me to do is now, if you look at my smaller triangles, now I have an angle on a side and an angle on a side. So I'm going to outline my two smaller triangles now. Now I still need something else, and this is a step that a lot of people overlook. But if you see here, I actually do have vertical angles. Angle WRX and ZRY are vertical angles, so don't overlook that step. So I can say angle WRX is congruent to angle ZRY. And how do I know that? Because vertical angles are congruent. So now that I have stated that the vertical angles are congruent, I can look at my two smaller triangles here outlined in blue, and I can notice that, okay, I have angle, side, angle, angle, side. Angle, angle, side. So since I have angle, angle, side, I could say triangle WRX is congruent to triangle ZRY by angle, angle, side. And that ultimately helps me show what I'm trying to prove, which is that WR is congruent to RZ, and I know that by CPCTC. So I can say WR is congruent to RZ by CPCTC. Okay? Alright, I'm done. Hopefully this works and uploads correctly. If you still have any questions, please feel free to email me or reference the other 2 videos. And if you're still not understanding it, make sure you come get help, come see me before you take part 2 of the test tomorrow. Alright, have a good night.